Hello everyone, thank you for coming. I'm really happy to be here opening this awesome day of conferences. And so as Daniel was saying, I'm going to talk about a project I did that maybe some of you saw already. I did that last April. It's how you can build a search engine using only CSS. And more specifically, it's how you can hack CSS to do a search engine. When I'm talking about hacking, I'm not talking about finding vulnerabilities. That would be for .security. What I'm talking about is this definition of hacking I really like. It's overcoming the limitations of a system to achieve new outcomes. In my case, the system and its limitation will be CSS, and the new outcome will be a search engine. And what I mean by a search engine is, for me, in its most basic form, a search engine is just a machine that will take keywords as input and will give you results as output. But I didn't want to build just any search engine. I wanted to build a great search engine. So I wanted one that was relevant, fast, and easy to use, meaning that my results should be really relevant to the keywords I typed. There should be no processing time. It should be instant. And I wanted people to use it that not think, oh, yes, it's just a clever CSS hack, but oh, it's just a search engine. So enough talking about what I wanted to build. What I'm going to do now is do a live demo of what I actually built. So this is the part where everything can just fail, so bear with me. So here is the demo. So this is the list of all the Algolia employees, about 150%. And you can search through the list by typing their first name, their last name, or their job titles. So if I want, for example, to find Lucas that I know is over there, I can search for Lucas, and you can see the results are displayed really quickly. The keyword I typed is actually highlighted in the results. And I can even, if I want, filter them by the one that is in the product team or the one that is in the design team. I can find myself as well by searching for Tim. But I can also find myself by searching by my Twitter handle, Pixelastic. OK, I can find you. And let's say I want to search for Nicolas. But I actually do a typo. And don't know if you can see that, but I actually type Niolas. I forgot one letter, and still I can find the right results, and they are correctly highlighted. So this is what I mean by it's relevant, it's fast, and it's easy to use. And all of that is done in CSS. When I started this project, I knew I wanted to do everything in CSS, but I also knew you also always need to have some HTML alongside your CSS, so I would need some HTML. And I still wanted to have my HTML markup as minimal as possible, and I didn't want to use any JavaScript. So in the rest of the talk, I'm going to explain how all of this actually works. But first, you have to understand the limitations of the system, the limitation of CSS. CSS has some limited support for stuff like variables, functions, loops, conditions, and regular expressions. Don't get me wrong, I'm not saying CSS cannot do any of the things. My point is, these are not the core building blocks of the language. Variables, conditions, and loops, they are core building blocks of many programming languages, but not CSS. And the trick is not to focus on what CSS cannot really do, but instead to try to understand what CSS is really good at and focus on that. And for me, where CSS really shines, it's with selectors. Selectors in CSS are really powerful. You can select by tag name, class name, IDs, the value of the attributes. You can even select based on where the element is in the markup, based on the ancestors or the siblings. And you can combine all of that. It means that you can have the most dirty and unsemantic HTML, but you will still be able to craft the perfect CSS selector to target exactly what you want. And this is, for me, what the main strength of CSS is, and this is what I'm going to use. Because this ability to select only the relevant items from a large pool of choices, when you think about this definition, it's actually what you would expect from a search engine. In a search engine, you have a large pool of potential results, but you are only interested in the ones that are matching your keywords. So I knew there was something to do here. If I could use the main strengths of CSS to build what search engine is, there was something to do. So let's see the markup and how it all started. Everything starts with that. You have an input that will act as a search bar, and you have an empty div. I just added an ID, so it's easier to select, but it's just an empty div. And I put some value directly inside the search bar. Then I can select specifically this input based on the value that is inside. So even if I set a value of team with a capital letter, I can still find it with an all lowercase, because if you use this lowercase I in the selector, it means it's case insensitive. So I can select my search bar, no problem. If on top of that, I add the tilde selector, I can select the element that is after it. And if on top of that, I also add a pseudo element before and a content, I can actually change the content of this element and style it completely differently. So when you get to that point, what you have is, based on the value of an input somewhere in the page, you are able to style and change the content of another element somewhere else in the page that is totally unrelated. And this is really the core of the whole hack on how everything is built. It's all great, except for one little drawback. It just does not work. Because when you load the page for the first time, your search bar is actually empty, because you want people to come here and type stuff. But when they do that, it does not actually update the value. The value is still an empty string, and this is what CSS will see. From CSS point of view, the selector is not matching anything, because the value you typed is just a value for the display. It's not actually what is in the HTML markup. So at that point, what I could have done is, OK, I will just press Enter. It will submit the form. And then on the server side, I will get the value, put it inside the HTML, and re-render the page. That works, but that's clearly not fast nor instant. So I needed to find another way. And what I actually did was to use some JavaScript. I know I said I didn't want to use any, but I couldn't find any other way. And I expect this room full of smart people to come to me afterwards and tell me how I cannot use JavaScript on this step. But as for now, that's the only option I found. But to be honest, the only JavaScript I'm using, it's just a one-liner. It's a non-input handler, so it means it will be triggered every time the value of the input is changing. And what it does is reading the value, because JavaScript can do that, and set it to the actual HTML value attribute. So when I'm actually now typing stuff is updated here. And so if I'm typing something that will match in CSS, it matches, and I have my results displayed. OK, that's nice, but I might be the only one named Tim inside the company, but we have several people named Alexandre, for example. And when I'm searching for Alexandre, I just don't want to find only one of them. I want to find them all. So I have to slightly change the markup to take that into account. What I'm doing is I'm keeping the same search bar, but instead of having only one empty div, I'm adding one empty div per potential result. So 150 empty divs. I'm pre-filling the content using CSS. So the first one will be Aurora, and the last one will be Zoe. In between, I have all the Alexandre, but I am not displaying them. They will be hidden. They will all have a display none by default, so you won't see them. You will only see them when there is a specific query that is entered in the search bar. So only when Alexandre is typed, then the blocks that are matching Alexandre will be displayed. But this is how everything is working. So we can see it in action here. So on the right, I have the list of all the divs. They are actually hidden. And if I do type Alexandre, the Alexandre are matching, and so are displayed. This is nice, but you might have felt it, what I was doing it. It seems a little slow. It should have been much better if instead of typing Alexandre, I was just typing Alex, and everything was matching already. This is the moment in the hack that I had to take a step back and really think about what I was actually building. So I could do the CSS tricks, it was OK, but I had to actually think about what am I actually building. I'm building a search engine, so how does a search engine work? And every search engine is made of two different parts that are called the indexing and the searching. The searching, it's easy. That's what you usually do when you're faced with a search bar. You're typing keywords in the search bar, and the question you are asking yourself implicitly is, what will I find if I type Alex? But when you are building a search engine, you have to ask yourself a very different set of questions. For every single potential result, you have to ask yourself, what should a user type so that this result is actually displayed? what should a user type to have Alexandre as a result. So you start making a table. Okay, to find Alexandre, I have to type Alex. But in the company, we have not only Alexandre, we also have Alexander, Alexandra, Alexandria, and all of those people, I should be able to find them just by typing Alex. But it's not just Alex, actually. It should be even better if just by typing A or Al, or every sequence of characters that will lead to Alex, I would be able to find them. And more than that, every actual sequence of characters that would lead to the final first name should display them. So once you've built this table, you just have convert that to CSS, something like that. So it's a lot of rules, but what it actually means is if the value of the input is A, Al, Ale, or whichever sequence of character leads to Alexandria, then the block of Alexandria should be displayed. And these sequences of characters in the search engine world, we call them n-grams. So you just have to generate all the n-grams that will lead to a specific result, and that's it. Well, no, that's not really it, because you have to do it for the last name and the job title as well. You also have to handle the accented characters. One of my coworkers is named Sébastien, with an accented E, and not everyone has a French keyboard and can do these characters, so I want people to be able to find him by typing his name with the accent or without the accent, meaning I have to create the n-grams with the accent or without the accent. That's also when you add synonyms. That's why I was able to find myself by typing my Twitter handle. I just added my Twitter handle as a set of n-grams to be able to find me. And that's also how I was able to find Nicolas by searching for Neolas, because you have to handle the typo tolerance, meaning that I had to generate variations of all the n-grams where there was just one letter removed. So that's a lot to generate. Everything is in CSS. That's a really, really large CSS file, but still everything is in CSS, and you have to do that 150 times for every single employee. But once you get to that point, you have a search bar where you can type almost anything and you will get results. Here, I'm typing Mar, and I have everyone from the marketing team, I have the salespeople that are mid-market, and everyone that has a first name or last name that contains or starts with Mar, even with some typos. That's nice, but this display can actually be improved. It would be much better if it was displayed that way. Those are the exact same results, they are just ordered differently. I have grouped all the matches in the first name, then matches in the last name, and matches in the job title. This is really important so you can understand why results are in this order. And this, fortunately, is really easy to do in CSS this time. There is no magic trick. Because all my displays are in Flexbox, I can just use the order property to change the order of the rendering, regardless of the order of the markup. But there is a last thing that is really important on that slide, and I will be finishing on that, is every single one of you in the room, you were able to understand how results were grouped by first name, last name, and job title, and that is because of the highlighting. The keyword I type is actually highlighted in the results. You have the first 3 characters that are matching your keyword. It's just bolded characters, but it's really important to tell your users, this is why this result is matching. And so I knew that for the easy-to-use part of my project, I needed to have some highlighting. But if you remember correctly, this is how I had content. It's a pseudo-element before with the content, and you cannot really add HTML inside of that, and you cannot really style with CSS something that is already in CSS. So I had to find another way. And the way I found is kind of cheating, actually. I took 2 fonts, the regular one and the bolded one, and I merged them together into one new font, but all the glyphs, all the bolded glyphs, I put in a specific namespace of UTF-8 that is called the private use area. It's a range of characters that are not used for anything, where you can put your own without overriding any existing glyphs in other characters. So I just put all my custom characters that are actually bolded version of the regular one there, and then I can access them in CSS just by using their CSS code point. It's absolutely unreadable, but you just replace every character you want to highlight with a custom glyph that looks like the bolded version. And I think you start to see where I'm going with that, but you have to do that with every single n-gram you generate. So it really creates a really, really large CSS file, and It's 8 megabytes at the end, 5 once modified, just to search into 150 employees. So if there is one thing I would like you to remember from this talk, it's please don't do it in production. There are way better ways to do search than doing it in CSS. But the whole point of this, it was a proof of concept. It was to see how far you can go with CSS. And it might have seemed completely crazy or even impossible at first. But impossible only means you haven't found the solution yet. And I can only encourage you to try to take a language, CSS or any other language, and try to make it do something it was not meant to be doing in the first place. You will learn a lot about what are the strengths and weaknesses of the language, and everything you will do with that language afterwards, you will have much more clarity about how to approach the issue. If you want to try any of those online, you can go on algolia.com/css/demo. The demo is there, you can try it. If you want to inspect the actual CSS, your browser may or may not crash. Use at your own risk, but everything is on GitHub. The whole code that generates the actual CSS is available. You can even pass your own JSON data as input, and it will give you the large CSS file as output if you want to try with your own data. And thank you very much.